All right, so I want to talk about what's called the first derivative test. And the basic idea behind the first derivative test is I want to imagine that I've got the graph of a function something like this. And I would like to figure out where the graph of the function is increasing. This should be a G. Decreasing. And then I'm looking for what are called local extrema. And so by a local extrema, I mean things like these points, which are usually called local maxima, and then something like these points down here, which are usually called local minima. And the idea is I'm just interested not in the highest value or the lowest value of the function, but the highest value in its immediate neighborhood. And the key to figuring out where those extrema are is noticing that at all of them, if you drew a horizontal tangent line, if you drew the tangent line rather, it would be horizontal. So if f of x has a local extrema at x equals a, then f prime of a equals 0, or f prime of a does not exist. And just as an aside, so here is an example of that second case. Think of the graph of the absolute value function. It has a local extrema, it has a local minimum right here, but because of this corner, f prime does not exist. But there's a local minimum there. And so in essence, what we're going to do is we're going to find the derivative of the function, identify the values at which the derivative is 0 or undefined, and these points are sometimes called critical points or critical values. So then what I can do is I can put those critical values on a number line. And this is just sort of a sketch drawing, so I'm not going to put numbers in now. But what you can see is that the function between two critical values, the function is either increasing everywhere or decreasing everywhere. And at these critical values, the direction that the graph is going always switches, although that's not always going to be the case, and I'll do an example in a minute where that's not the case. And so you can figure this out, where this is happening, by finding the derivative of the function and figuring out when the derivative is positive and when it's negative. And so we can solve some inequalities. So let's say we've done that. Let's say that I've got some function f of x. I know that f prime of x equals 0 at x equals -3, 1, and 5. Then I can put on a number line, I'd put -1, or -3 rather, sorry, 1 and 5 like that. And then what you can do is you can plug values into the derivative to figure out where the derivative is positive and when it's negative. And so let's say for a second we do that with some function f of x. and the graph goes positive, positive. The derivative is positive, then negative, then positive. Well, so if the derivative is positive, that means the original function is increasing. And if the derivative is negative, that means the original function is decreasing. So then what we can do is we can draw some axes, and we can find some points. Usually what you do is you'd figure out where f of 3 equals, what f of 1 equals, and what f of 5 equals. And so then plot those points on the graph. But the general idea here is, let's say this is -3, this is 1, and this is 5. So the general idea of what's happening here is the function is increasing until -3, and at -3 it should level off. But then to the right of -3 it increases again. And then at 1 it increases until x equals 1, and then it decreases again. And then you keep going, and at 5 you have a derivative of 0 again, so it levels off. And then if x is larger than 5, the function is increasing, and its graph looks something like this. And so basically what happens is, if the graph goes from increasing to decreasing, you get a local max. And if the graph goes from decreasing to increasing, you get a local min. But if it's increasing on both sides, then it's neither. You get a little, it flattens out, but it doesn't really stop. All right? So let's see. All right. So let's try one more. Let's say I give you a number line. So here's f of x, here's f prime of x. And let's say you do find the derivative, you figure out its zeros, these are its zeros, and then you figure out that the derivative goes positive, positive, negative, negative, positive. So based on this information, can you tell me where there's a local max and where there's a local min? Well, so the easiest way to think about it is, again, positive derivative means the function is increasing, and negative derivative means the function is decreasing. And if you look at the number line, you can see that at -1, the graph is doing something like this. So that tells me you have a local max when x is -1. And similarly, at 7, the graph is going to do something like this. It decreases and it increases. So at x equals 7, you have a minimum. And then at 2, right, what's going to happen is it's going to go decrease and it's going to go like that. So it's not going to change direction. And at -4, it increases, then it levels off, then it increases again. So again, you don't get a local extrema. All right. So this is the basic idea. Let's apply it to something. Let's try the function f of x equals x cubed minus 3x plus 5. So I'm going to take the derivative of f of x, and what's that? Well, the power rule says I get 3x squared minus 3. And now I'm going to find critical values. And I'm going to find critical values by setting 3x squared minus 3 equal to 0. And then I'm going to solve for x. So what I can do is I can factor 3 out, and I get 3 times x squared minus 1 is 0. And then x squared minus 1 is a difference of squares. And remember that if you've got a squared minus b squared, that's the same thing as a plus b times a minus b. So I can rewrite this as 3 times x minus 1 times x plus 1 equals 0. And so that tells me my critical values are x equals 1 and -1. All right. So now what I'm going to do is I'm going to draw a number line. Negative 1 goes here, 1 goes here. So now what I'm going to do is I'm going to come up with what I call test values. So I'm looking for a number. So this section of the number line corresponds to all values of x less than negative 1. This chunk of the number line corresponds to values between negative 1 and 1. And this chunk of the number line corresponds to values larger than 1. So my test value should be, in this case, a number less than 1, like maybe negative 3. Between negative 1 and 1, 0 is between negative 1 and 1. And if x is greater than 1, well, positive 3 is greater than 1. And so then what I'm going to do is I'm going to figure out what 3x squared minus 3 equals. And so you can just plug this into a calculator. You get 27 minus 3, which is 24. So if f prime of x is this, then f prime of negative 3 is 24. That means that f prime is positive, which means f of x must be increasing. Now, if x is 0, then 3x minus 3 is 0 minus 3, which is negative 3. That's a negative number, so the function is decreasing. And then last but not least, if you plug in 3, you're going to get 27 minus 3 again, which is positive 24. So the function is going to be increasing. Okay, so that means I have a local min at x equals negative 1, and I have a local max at x equals positive 1. So I'm going to plug in f of negative 1, the original function, so that's negative 1 cubed minus 3 times negative 1 plus 5, which is negative 1 plus 3 plus 5, which is 7. And f of positive 1 is 1 cubed minus 3 times 1 plus 5, which is 1 minus 3 plus 5, which is 3. So I go down here and I draw some axes. Here's negative 1, here's negative 2, here's negative 3. Same thing over here. And then 1, 2, 3, 4, 5, 6, 7, 8. All right, so it goes to the point negative 1, 7, so I'll plot the point negative 1, 7, and it goes to the point 1, 3, so I'll plot the point 1, 3. Now, technically, in order to do this properly, I should also solve x cubed minus 3x plus 5 equals 0, but that's hard, so I'm going to skip it. But what I can also tell you is that if you plug 0 in, you get positive 5, which means that this graph should go through the point 0, 5 as well. So, okay. So if x is less than negative 1, f prime is positive, which means f of x is increasing. Then between negative 1 and 1, f prime is negative, so f is decreasing. And then when x is larger than 1, f prime is positive, so f is increasing again. And so your graph of your function is going to look roughly like this. And that's the basic idea behind graph sketching.